Okay, hello. Finally, I'm able to invite you to try out Impact. Impact has been a project that's been a little bit on and off for about a year. And the reason for that is there's been these surface problems that's caused a lot of tension with state management for me over the recent time. And it's been difficult to analyze exactly what the root cause of that has been. But through a lot of iterations, testing, discussions, streams, I've figured out what the issue actually is. And Impact is the result of trying to fix that. So there's been a few iterations of Impact itself after finding the tool that helps resolve these issues. But now we're at the stage where, yes, this is the signature, this is how it's going to look, and this is what it's going to do. So who is Impact really for? Well, Impact is coming from this experience of building complex productivity apps, which is heavy state management on the client. That doesn't mean that you can't use it for simpler things. But if you do like heavy server-side rendering where it's only about like syncing data with the server, then Impact isn't going to help you that much. It's going to help you where you have complexity of state management in the client itself due to a lot of interactivity and different parts of the UI and so on and so on. So what we're going to talk about first in terms of what Impact tries to resolve is how reconciliation differs from observation. And there are like two things we do when we build apps. We build the UI or express the UI, and then we express the state management. Now, reconciliation is amazing for expressing UI. And the reason for that is that we can just use the language. And with TypeScript, we also get complete native type support. So in React, we can create a function component, and we can just use JavaScript or TypeScript to express the dynamic nature of that UI. So whenever some dependency changes, the function is called again, and React will reconcile the differences and update the DOM. This is a really, really good developer experience. But when it comes to state management, React introduced hooks to kind of keep this component as a function, which is great. But now you have state management on top of the reconciler. And this creates a lot of mental overhead. It also creates performance issues, but the mental overhead is really the most problematic part when you do state management, because in this case, we're just going to create an interval that updates the count. But to be able to do that, we need to have this generic use effect, which is kind of a subscription type of primitive, but we're creating an interval and we don't think about subscriptions. And then we have this dependency array, and that's an overhead, because that controls the staleness of the scope of the effect itself. And then we define the interval, but then we have to be careful when we actually change the count, because we can't reference the count. We have to use the callback version of this. And then we also have to clear the interval by returning a function, which is the disposer of the subscription inside the effect. And then we have strict mode on top of this, which will run the component function twice, and then it will run each effect twice. And there's just so much overhead to doing state management. But then we can flip it around. If we do observation on the UI, it actually isn't that great of an experience. And the reason is that now the component function, it only runs once. And you would intuitively think that's a good thing. But what happens is that now you can't just use JavaScript to express the dynamic nature. You need these special primitives that's built for observing state and props to do the dynamic behavior of the UI. But now you're not using the language anymore. So now it's very difficult to get that to work with typing support, for example. But when we look at state, now it starts to make a lot of sense, because now this function only runs once, and we can just create some state. We can start our interval, we can just update that state, and then explicitly we'll clean up that interval whenever this state goes out of scope or is dereferenced in the runtime. So the conclusion of this is that if we observe state and reconcile UI, we're building UIs with this really great developer experience of reconciliation, and then we're doing state management with this really great developer experience of observation or reactivity. And this is what Impact is trying to kind of bring together. Now, the thing is that if we're going to combine these two concepts, we need to figure out how to like organize that. And to talk about that, we're going to talk about like how we traditionally think about organizing state management. So first of all, we have like props passing, like you implement some state inside a component. And if you need to share that state with anything else, like you reach like the complexity is just another component, right? Which you very quickly reach in React. You will have to pass this as props, and then you have to consider memoization and so on to avoid unnecessary reconciliation. But then typically this gets too complex, and then you go to a context. And the context allows you to co-locate state management and share it with a bunch of components, like at any nested level. You kind of inject the state management where it's needed. But this is also a problem, because now the performance issues becomes even more troublesome. One thing is like defining state management within the reconciler, which has the mental overhead, but here it's really a performance issue. And the reason is that in a context, for the consuming components to update, the actual context value has to change. But that context value represents all your state management within that context. So if you have one component that just looks at one tiny piece of state inside that context, it will reconcile on any change. And then you might split up the context for performance reasons. And then you nest one inside the other, and it becomes very artificial and problematic if suddenly the parent context needs state from the nested context, because they're really the same domain, but you split them up because of performance. And yeah, so when we get to this point, we kind of say, fuck it, let's just go global. That's global. And we take on a new paradigm. We take on a reactive paradigm, which is expressed in many different ways, with many different types of encapsulations. Like you have reducers, you have classes, you have declarative stores, you have functional stores. Like there's all kinds of different ways to do this. And that certainly helps with the friction. And this is kind of where we're at today. But we lose something when we go away from the context. And what we lose is what's called state dependencies. So when you think about global state, you're forced to make everything global. Like it sits there together. And you have to manually manage state dependencies. So what do I really mean here? So looking at this simple state, the posts in this dashboard actually depends on the user. It's tied to the user, so there's a dependency there. So that means if the user changes, the post should also be changed, so they don't leak into the wrong user. But when you put everything globally, that needs to be manually managed. And the same goes for the selected post ID here. If you change the selected post ID, you have this selected post that has some like state related to that selected post. It's not the post itself, but it's a related state to the selected post, right? And again, you have to manually manage this so that the state of looking at one post doesn't leak into the other post. But maybe the most important thing about this is if you're using TypeScript, because when you have global state, you have to define all the state and you consume it globally. So that means, for example, the user here, you don't have a user to begin with, but you resolve a user. But now you have to type that user as being there or not being there, which means that in any context where you consume the user, you have to tell TypeScript that, oh, by the way, in this context, there is actually a user. And the result of that is maybe you turn off strict null checking, maybe you do the exclamation mark to just override the type, or maybe you do a conditional, like if no user, just return. But you know that there's always a user in that specific context. So this is really what we leave behind when we go global. So the way Impact resolves this is that instead of just having global state management, we build on top of the existing context. Instead of having a reconciling context, we have a reactive context, and that allows us to have nested stores that's mounted with the component tree, just like a normal context. So as an example here, like again, it's a simple example. We're trying to deal with complexity, but to understand the fundamental concepts, we need to show something simple. So bear with me here. The thing is that Impact is really about the store encapsulation and how that works. It doesn't force you into any new state management primitives. So that means that you can use Mobx, you can use Preact, you can use Legend, or you can use the signals implementation that comes from Impact. But Impact really supports any kind of state management primitives. And the way you define a store is that you create a function, much like a hook. And this function can take props that comes from React because you're mounting this store in the component tree. And it also has a cleanup function that's used to clean up any side effects if you have them. So that when this store unmounts in the component tree, this cleanup will actually run. So what we see here is that I'm just taking an initial count from the props. I create a signal of this count, which increases every second. When it cleans up with clear interval, I expose the count and I expose the possibility to reset that count. From the perspective of the component, you can now just use the hook, the use App Store hook here, and you can decide which component is going to be the provider of this store. And in this case, we're exporting the app component, which is going to behave as the provider. And doing so, that app component also gets access to the App Store itself, but any nested component will also get access to it. The really interesting thing about having this strong, clear encapsulation of state management is that we can actually automate observation. So Impact has an opt-in bubble plugin that just looks for any component that uses a store, and it will automatically add the observer and optimize reconciliation for those components. So we're basically making all these observer higher order components disappear in your code. And we can do that because we have this strong concept of a store. So in this case, what's going to happen here is that when I click the reset, it's going to reset the count in the App Store. And when the count changes, it's going to update the counter component. So the app won't actually render again because it's not observing the count, right? So the reset will only reconcile the counter in this case because that's where the count is actually being observed. So the way you can think about this is that Impact is this abstraction of a reactive context. It builds on the existing React context and just makes a reactive or creates a reactive scope on top of it. And it's actually concurrent safe. So if you have side effects in your store, you're able to do this reliably with concurrent mode. And as you saw, you have the cleanup function to actually clean it up. But Impact ensures that the cleanup actually runs also in concurrent scenarios. With this encapsulation of a store, we're able to add automatic observation to components. So all these higher order components kind of just disappears in your code using the Bubble plugin if you want to do that. And it's just kind of like a component. So fast refresh just works out of the box. Also for stores that has side effects. So what this basically means, it's kind of like one store to bind them all kind of thing. This is not to say that this is the only abstraction needed for stores. If you're fine with doing like a very high abstraction declarative global store like Zustand or Jotai or one of those, please use them. Whatever works for your project. But as the complexity increases, you might consider something like this, because then you can choose what reactive primitives you want to use. So you can use Mobx, for example, which lets you do normal mutation. So the state there is basically just objects which you can point to and change, and observation kind of just works. But you might also want to use something like Legend, which has a more explicit API for getting and setting state. You have Preact, which uses this .value signature. And then you have Impact, which has more of a solid.js type of API or signature for its reactive primitives. And there are other benefits of using these different solutions. But the point is that you need some way to encapsulate and expose it to components in a predictable, reliable way. And that's what Impact offers. So with that, I'm so relieved. It's been so many streams. I've been super excited. I've been so to the point of depression, kind of almost giving up on React. Like, why do I feel all this friction with state management? But this is really the thing that solves it for me personally, and with the experiences I've had building complicated productivity types of applications. And I hope it can help you as well. So thanks for listening.